Hello everybody. Good morning. It is 10:05, Wednesday, the 14th of April, and we're going to be talking about using trigonometry and our calculators. Okay, so in the last lesson we introduced, we as in me, introduced the three primary trigonometric ratios for right triangles. So let's first review these real quick. Okay, so remember that sine is some old hippie caught another hippie taking Opal's apples. Okay, I'll make it appropriate. All right, so some old hippie caught another hippie taking Opal's apples. Okay, so anyway, in the last lesson we introduced three primary, Bubba, I just read that. Hello. Given the right triangle shown below, answer the following questions, determine the following trigonometric ratios, leave them in fraction form. Okay, so we look at A. This is our opposite. This is our adjacent. This is our hypotenuse. Okay? So, sum. Come on. I don't know what's going on here. Sum. I can't see the triangle. There we go. All right. So, sum. Old hippie caught another hippie, okay, tripping on, well, taking Opal's apples, okay? Now remember, we can't leave stuff with a radical in the bottom here, okay? Not sure if you guys recall that, but you cannot do that. So what we have to do is we have to multiply top and the bottom by square root 3 over 3. And what it does, whoops, not equals, multiply, hello. What it does is it cancels this one down below and just leaves you with a, what is up with this pen? It leaves you with a 3 down below. Okay, so anytime you multiply square roots like this, okay, radicals, what happens is you end up putting them both underneath the radical using the product property. You get square root 9. And what's the square root of 9? Well, that's 3. Okay? All right, so that's how you take care of radicals in the denominator. We're not allowed to have those. Okay? So now, the next one. All right, it says the sine of C. Okay, so let's rewrite these things. Now, the hypotenuse always stays, but we're just going to change what the adjacent and the opposite are. Okay? So, some old hippie, whoops, caught another hippie, okay, taking Opal's apples, which will be just square root 3. Okay? So, what is the relationship between the sine and cosine of complementary angles in A and C? Okay? And so the relationship is, let me read this again. What is the relationship between the sine and cosine of complementary angles, A and C? Okay, so the sine of A, okay, is equal to the cosine of C, and the cosine of A is equal to the sine of C. All right, and that's the relationship those guys have. Okay? Now remember, they're complementary in the sense that these two must add up to 90, right? So remember what it means to be complementary angles. Complementary, remember the trick, 90 degrees, right? Supplementary, 80, 180, right? Okay? So just keep that in mind. Don't forget that. Still an important term here. Okay? So it says using your calculator to help and making sure it's in degree mode. Okay, so make sure you guys do that. You're going to go to mode. And you go down and you see where radians selected. You make sure you go over and select degree. Okay, then you hit quit and get out of there. It says determine which of the following angles is correct for A using a guess and check scheme. Now, here's what we're talking about. Okay, so for any triangle that has 20 degrees, 30 degrees, 40 degrees, or 50 degrees, okay, in this bottom left corner here, right? What it's saying is there's going to be a particular ratio no matter what the size of this triangle is. As long as this is a 90-degree angle and this is one of these angles, we'll just say 40, okay? The sine and cosine and tangent, okay, relationship that comes from the ratios here. So let's just say, you know, sine of 40 degrees is your over h, right? So what that's saying is that for any triangle that carries, move that out of the way, okay, that carries both a 90-degree angle and a 40-degree acute angle, okay, the opposite over the hypotenuse, that ratio will always be the same, right? So let's just find out what the sine of 40 degrees is, okay? So the sine of 40 degrees, make sure it's in degree mode, is equal to okay, so let's do it right. Okay, so sine of 40 degrees is equal to 0.64. Okay, so let's find the sine of 50 degrees. Okay, sine of 50 degrees, that's 0.766. Okay, sine of 20 degrees. That is, whoops, 0.34, and the sine of 30 degrees, whoops, is 0.5. Okay, if I can get it to right. So, here's what we're looking for, okay? So, for all four of these angles, okay, the ratios that they get when you take your angle, whatever that may be, and you utilize the opposite over hypotenuse, okay, as long as your angle measures, right, are consistent, either with, you know, 20 degrees, 40 degrees, whatever, okay, that relationship, your opposite over hypotenuse, will be the same no matter what the size of that triangle is, okay? And so that's what was really important about that last lesson, was getting through to you guys that in order for this to work, these right triangles have to be similar, right? And so one of the similarities was that you needed two congruent angles. So as long as they have a right angle, and let's just say we're talking about 20 here, okay, that relationship, no matter what the size of that triangle is, that ratio will always be the same. Just like when we were looking at those similar triangles where the one was like a 2-to-1 ratio, right? And so the one triangle was, you know, twice the size of that one. It didn't matter, no matter when you set up these ratios, these sine, cosine, tangent ratios, you still ended up with the same ratio. So that's what I'm trying to drive forward here. So now, let's take a look up here and see, okay, which one of our sines, okay, equals one of these numbers here. And hopefully it's just screaming out at you, okay? I see the sine of 30 degrees is equal to 0.5. And I look at sine of A, I know that this is also 0.5. It says leave in fraction form, but clearly, right, 1/2 is equal to 0.5. So, what this is saying is this, okay? This angle must be 30 degrees because no matter what the size of the triangle is, okay, no matter what the size of the triangle is, okay, so let me just make up some numbers here, okay? Well, I'm not going to make any up, but, okay, as long as you have 30 degrees here and a right angle there, these two triangles will be similar, and therefore the ratio of your opposite over hypotenuse will always be the same, okay? And so that's what I was trying to drive forward. So anyway, the answer for this is 2, okay? Because as you can see, right, our sine, or our ratio of angle A, right, has to be 0.5. And then the sine of 30 is also 0.5. So what that is saying is the ratio from that opposite over hypotenuse for our 30-degree acute angle and a 90-degree will always be 0.5. Okay? So anyway, let's go on to exercise 2. So it says, which of the following is the closest to the length of MN in the diagram below. Think which of the trig values, or think about which of the trig values to utilize. Use your calculator and determine, and check to determine. Okay? So here's the angle we're talking about here. All right, so let's think about what they're actually giving us. Here's our adjacent, here's our opposite, here's our hypotenuse. Okay? And we're looking at which is the closest length of MN. Okay? So what we're going to have to realize here is that we're going to have to use one of our specific trig ratios. More importantly, the one that involves the side MN and the side ML, because ML is that's the only number we have. So the ones that use opposite and adjacent, okay, is your tangent. All right, so the tangent of 42, okay, must also be equal to the tangent of angle L. Okay, and so let's just say, so in this case, angle L, right, is, well, it's 42, right? But we don't know what MN is. So if we were to write this, right, it would be opposite over 20, right? And so what we're looking for is we're looking for our opposite, right? And so we have to think about which one of these makes the most sense, which one gives us the same ratio. So what we're going to have to do first, we're going to have to find out what the tangent of 42 is, okay? So for any acute angle that is, 90 is a 42, the ratio for the opposite over adjacent will always be the same. So the tangent of 42 is equal to 0.9004. Okay? So it says think about which of the trig ratios to utilize, which we did. So we're going to use tan, okay? And then use your calculator to guess and check which one of these will work, okay? So now, what we need to look for is we need to get it so that our opposite over 20, right, our ratio is going to be equal to 0.9904, okay? So, a couple ways we could go about this. We could, we could just kind of solve it like we have right here, right? I'm going to multiply both sides by 20, and so multiply that by 20, and I get my opposite side is equal to 18.008. And so which of these would be the closest to the length? Definitely 18. And then also, all right, if you take 18 and you divide it by 20, what do you get? You get 0.9. So 18 divided by 20 is equal to 0.9. So again, that ratio, we're looking for whether or not we're getting that same ratio that we're supposed to have when our tangent is 42 degrees. Okay? So our answer here is 3. All right, in the right triangle ABC, angle A is a right angle, and the measure of angle C is 34. Okay, so let me draw this guy in here. So we'll go A is the right angle, right? So there's A. C is 34. So we'll just make that one C, and we'll make that one B. Okay, so it says which of the following would most likely closely match these conditions. So what we need to figure out, okay, is which one of these will be the correct ratio when our angle is 34 degrees. Okay, so we can use any one we want, I think, right? Well, let's see. Actually, they're giving us different ones, right? So let's start with the first one. So they give us 18 and 12. Okay, so this would be our opposite. This would be our hypotenuse. And so the trig ratio that we would have to utilize there would have to be the sine function, right? Because sine involves opposite over hypotenuse. And so, in this case, opposite over hypotenuse, so the sine of C is going to be 18 over 12, right? Okay. And 18 divided by 12 is 1.5. Okay? And so, what I'm going to do now is I'm going to see, well, what's the sine of 34 degrees? So the sine of 34 degrees is 0.55. Okay? So that one can't be it. Let's go to the next one. They give us AB and BC again. Okay. So AB is 14, BC is 25. Let's do the same thing. Okay, so again, I'm looking at whether or not I'm getting the same ratio that I should get when my angle is 34 degrees. So I'm going to go 14 over 25. Ooh, I'm getting 0.56. Oh boy, this one's a potential. Okay, let's just verify the other two. Okay, so AC, actually this is all going to stay here, right? So this will be our adjacent. All right, so AC is 11, BC is 17, and so for this one we would have to use cosine, right? Because we need our adjacent and our hypotenuse ratio. So cosine of 34 degrees is 0.82, and cosine is adjacent over hypotenuse, so in this case 11 over 17, and we get 0.64. So that one's out. And then finally AC and AB. So AC is 15, AB is 12. And so for this one we would have to use tangent. Okay, so the tangent of 34 is equal to 0.67. And 12 divided by 15, again this is the ratio for tangent. 12 divided by 15 is 0.8. So this guy's out right here. So our answer is 2, because that's the only two sides that match up with the ratio of what the sine of 34 degrees is. Okay, so the ratio you get from that opposite over hypotenuse for a 34 degree angle will always be 0.55. Okay, so that's the closest one that will work. Okay, so in the old days, instead of having a calculator, students had to read the trigonometric ratios from a table, considering the following problem that uses both the table and your calculator. Okay, so a partial table of values for the sine, cosine, and tangent ratios is given. Okay, so this is what they used to have to do back in the day. I don't remember this, okay, but maybe some of you guys' parents might. Okay, so it says use your table or use your calculator to verify a few of the values this table by using it to evaluate. So anyway, so the sine of 28, right? They want us to use our calculator. So the sine of 28 is 0.4694. So what that is saying, that any triangle, ignore these things here, right, that has 28 degrees here, okay, its opposite over hypotenuse, that ratio will always be this number right here, no matter the size of the triangle, okay? And so, does that match up with what we have here? Sure does. Okay? Tangent of 33, okay? So, again, what this is saying is that when we have a 33 degree angle, or opposite over adjacent, that ratio, no matter what the size of the triangle, as long as I have those two particular pieces, is always going to be 0.6494, which is right there. Okay? All right, so hopefully this is starting to sink in. Maybe not. I'm not too sure, because I'm just kind of talking to myself right now. But anyway, given the right triangle shown below, which angle in the table is closest to the measure of angle A? Explain your answer. Okay? So, we can use any one we want, all right? Actually, we can't. We're going to have to use our opposite over adjacent. Okay? And so the only trig ratio that involves those two pieces is tangent. All right? So our opposite is 20, whoops, not 200, over our adjacent, which is 41. And so 20 divided by 41 is equal to 0.4878. Okay, and so let's take a look up here. Which one of those is the closest? This guy right here. So this must be 26 degrees. Okay. This is explain how I think that's pretty self-explanatory. You had to use tangent there. Okay, so using your calculator, evaluate the following. Now this is going to get a little different, right? So this is what we call the inverse trig functions. Okay, and so don't look down there. All right, no cheating. All right. So let's explain what that is. So if you look above your sine, cosine, tangent, you'll see that we got sine to the -1, cosine to the -1, tangent to the -1. Okay, so I want everybody to follow along here. So you're going to have to hit second. So second sine, and then you're going to type in 0.4384. And what do we get? 26.001. Okay, second cosine of 0.8290. All right, so inverse cosine, what do we get? We get 34.003. And the inverse tangent of 0.6009 is 31.001. So, I want you to take a look at this though. The sine, when it was 43.84, lo and behold, what do we have here? Oh, we got 26.001. And then over on this one, all right, when our cosine was 0.8290, right here. What was our angle measure? 34 degrees, right? Okay, and then finally, we'll go nice brown here. Okay, when our tangent was 0.6009, our angle measure was 31, which is what we got right here. So what this inverse function does is it actually gives you the angle measure. Okay, so the inverse sine, inverse cosine, inverse tangent will all give you the angles as their outputs and has their inputs as the actual ratio from your triangle. Okay, so in the final example here it says, given the right triangle below, determine the measure of E to the nearest degree by using your calculator and one of the inverse trig functions. Okay, so which angle are we trying to find? We're trying to find E. Okay, so that's our first step. Next step, let's label what they gave us. So this is our adjacent, this is our hypotenuse. Okay, so which trig ratio allows us to use our adjacent and our hypotenuse to sort of find that ratio? Okay, that's going to be our cosine, because cosine of E is equal to A over H. Okay, so let's just put that in. So A is 8, that one is 11, so we get the cosine of E is equal to, well, 8 divided by 11 is 0.7272, ... Okay, and then we're going to take the inverse. So we're going to go second cosine, and we're just going to type in that number right there. And by doing so, we end up getting E is equal to 43.34 degrees. And that is the measure of that angle. Okay? Now, just for fun, just because, well, I'm not trying to torture you guys. Here we go. Okay, just for fun, if this is 43 something, and these guys are honestly complementary, let's figure out what this other angle is going to be. Okay, so let's just find the measure of angle C. So the C is going to use, well, instead of adjacent, if we're talking about angle C, this is now our opposite angle. So to find the measure of angle C, I'm going to use sine. Okay, so the sine of C is equal to the ratio opposite over hypotenuse. So in this case, this is going to be, again, 8 over 11. All right, and so (8 over 11 is 0.772, so I'm going to go the inverse sine to both sides. And by doing so, I get C is equal to 46.658. And lo and behold, add those together, 46.658 plus 43.34. We get 89.998, okay, which is darn near close to 90, okay, so I'm pretty satisfied. All right, so anyway, hopefully this sort of helps you guys out, those of you who are watching it. I know this stuff is very difficult, guys, so don't be afraid to ask questions. We will work through this the best we can, okay, and good luck.